Next, we're going to add matrices. When adding matrices, the size of the two matrices that you're adding must be the same. And the resulting matrix will also be the same size. So we're simply going to add each corresponding element to create the sum of matrices. So before I start, I want to just make sure I know what the sizes of the matrices are to see if this is even possible. So matrix A is going to be a 2 by 3 matrix. Matrix B is a 3 rows by 2 column matrix. Matrix C is a 2 rows by 3 columns matrix, and D is 3 rows by 2 columns. Now we are going to find the following sums. A plus C. Well, A is my 2 by 3 matrix, so 1, 3, 5, 2, 4, 6. And I am going to add that to C, which is another 2 by 3 matrix, 4, 9, negative 5, 2, negative 11, 3. And to get the sum, I'm going to have another 2 by 3 matrix. So if you want to make a matrix, and you can put little blanks there if you want, just to remind you that you're going to have 2 rows and 3 columns. And to get the answer, I'm just going to add the corresponding parts. So if I add 1 plus 4, that's going to get me 5, and I'm going to put that in the resulting first row, first column. Next, I have this first row, second column, 3 and 9. So when I add those two together, I can get 11. The next one I have is 5 and plus negative 5, and 5 plus negative 5. That's going to get me 0. On the second row, first column, I have a 2 plus a 2, and that results in 4. Next, I'm taking 4 plus negative 11, and that adds to negative 7. And the last one, I have a 6 in the second row, third column, and a 3. And when I add those together, I get 9. And so this is my resulting matrix. Our next problem says to add A plus B. So A is 1, 2, 5, 2, 4, 6. And I'm adding matrix B to it, which is my 3 by 2 matrix, 9, 8, 7, 6, 5, 4. Well, you can clearly see that these two matrices are not the same size. Matrix A is a 2 by 3 matrix, matrix B is a 3 by 2, so automatically we can say this is not possible. I cannot add matrix A and matrix B because they're not the same size. Next, I'm going to add matrix D, which is a 3 by 2 matrix. And I'm going to add that to matrix B, which is also a 3 by 2 matrix. Notice that because they're the same size, my answer will also be a 3 by 2 matrix. So I am going to add the corresponding parts. 1 plus 9 is 10. 5 plus 8 is 13. 6 plus 7 is 13. 23 plus 6 is 29. 12 plus 5 is 17. And 2 plus 4 is 6. Excellent. Now our next problem says B plus D. So my B matrix is 9, 8, 7, 6, 5, 4. And I'm adding that to 1, 5, 6, 23, 12, 2. Notice they're both a 3 by 2 matrix, so the answer will also be a 3 by 2 matrix. I'm going to add the corresponding parts. 9 plus 1 is 10. 8 plus 5 is 13. 7 plus 6 is 13. 6 plus 23 is 29. 5 plus 12 is 17. and then 4 plus 2 is 6. What do you notice here? When I added D plus B, and then I added B plus D, the result was the same. So D plus B is the same as B plus D. This means that matrix addition is commutative. That means it doesn't really matter what order you put the matrices in. If they're the same size and they're able to be added, you can add them in either order and the answer is going to be the same. So this is very similar to regular addition. Regular addition, like if you have 2 plus 3, this is the same thing as 3 plus 2. This is the commutative property. So it works in matrices as well, which is interesting. Next, we're going to subtract matrices. So when you're subtracting matrices, the size of the matrices must be the same, and the resulting matrix will also be the same size. We're going to simply subtract each corresponding element to create the differences of matrices. So again, I have matrix A, which is a 2 by 3 matrix. Matrix B, which is a 3 by 2 matrix. Matrix C, which is a 2 by 3 matrix. And matrix D, which is a 3 by 2 matrix. So now we're going to find the following differences. Our first example is A minus C. So my matrix A, we have 1, 3, 5, 2, 4, 6. And we are subtracting C. And my C matrix is also a 2 by 3, 4, 9, negative 5, 2, negative 11, 3. So because both of my matrices are a 2 by 3, the result is also going to be a 2 by 3. Now I'm going to show one extra line of work here on the subtraction because more students make mistakes on the subtraction than they do on the addition because they start subtracting on the first row, but then halfway through they kind of forget what they're doing and then they start adding. So it might be to your advantage to actually write this out. So I have 1 minus 4 for the first row, first column, 3 minus 9, 5 minus a negative 5. Notice there's a minus because we're subtracting matrices and there's a negative on the 5. And then 2 minus 2, 4 minus a negative 11. Again, there's a minus because it's a subtraction problem and a negative because 11 is already negative. And then 6 minus 3. Once we have that written out, then you can actually do the computation. We have negative 3, negative 6, minus a negative. When we have 5 minus a negative 5, that's really add a line, change the sign, so that adds up to 10. Okay. 2 minus 2 is 0. 4 minus a negative 11, add a line, change the sign, that's really adding up to 15. And then on the last one, 6 minus 3 is 3. So that is going to be matrix subtraction. On our next problem, we have matrix A, which is a 2 by 3, 1, 3, 5, 2, 4, 6, and we are subtracting B, and B is a 3 by 2 matrix. So this 3 by 2 matrix, 9, 8, 7, 6, 5, 4, is not the same size as A, which is a 2 by 3. Automatically, I can stop my problem and just write not possible. The matrices have to be the same size in order to be able to add them. Next, we're going to take D minus B. So my D matrix is a 3 by 2, 1, 5, 6, 23, 12, 2, and we are subtracting B, which is another 3 by 2 matrix, 9, 8, 7, 6, 5, 4. So I'm going to show my work here. I'm going to take 1 minus 9 for the first row, first column, 5 minus 8, 6 minus 7, 23 minus 6, 12 minus 5, and then 2 minus 4. So this results in -8, -3, -1, 17, 7, and -2. Okay, so let's do this again, but this time I'm taking B minus D. So my B matrix, which is a 3 by 2, and I'm going to subtract my D matrix. Now the D matrix is also a 3 by 2. So the result is going to be another 3 by 2 matrix. Now I'm going to actually show my work here again, just so I don't make any subtracting mistakes. So we get 9 minus 1, 8 minus 5, 7 minus 6, 6 minus 23, 5 minus 12, and then 4 minus 2. So let's clean that up a little bit. 9 minus 1 is 8, 8 minus 5 is 3, 7 minus 6 is 1, 6 minus 23 is -17, 5 minus 12 is -7, and 4 minus 2 is 2. What do you notice about these two matrices? Notice that D subtract B is not the same thing as B subtract D. This means that matrix subtraction is not commutative. But that's true of regular addition. If I had 5 minus 3, that's not the same thing as 3 minus 5. So regular subtraction is not commutative, and neither is matrix subtraction.